Is it okay now? I think.
Yes, sir. Yes, sir. It's okay now,
Okay.
sir.
How is Indore doing? All well?
All well, sir.
Okay.
So just give me a second. We'll introduce
Yeah.
and then we'll start.
Please take your time. I'm comfortably sitting in my office. Thank you.
So we have with us Dr. Nitin Goyal, sir, who is a principal scientist and head CSIR-NEERI Mumbai Zonal Centre. He is a graduate in civil engineering, postgraduate and PhD in environmental science and engineering with 23 years of professional expertise in environmental engineering and numerous research publications and award-winning projects. He is a guest researcher. He has been a guest researcher at the Desert Research Institute, Reno, Nevada, USA, and he has also been awarded the Young Scientist Award from the Department of Science and Technology, New Delhi. He is currently working on air quality management studies with several state pollution control boards in India, which is in collaboration with IIT Bombay and IIT Kanpur. And the topic which he will be discussing today is restoration of lakes and water bodies, specific field experiences. I thank you so much, sir, on behalf of IPS Academy Civil Engineering Department for accepting our request and being here with us today.
Thank you so much for your kind welcome. I would start by sharing my slides. Um, are my slides visible?
Yes, sir.
Okay, so the title of my talk today was Restoration of Lakes and Water Bodies. Is the slide visible?
Yes, sir. It's clear, sir.
Okay, great. When I was going through the contents, I thought that let me reiterate some of the things which I wanted to talk about. So um, let me start by this slide, just for the sensitization of the students and the faculty members and other dignitaries in this talk. What are these wastewater issues? So, as per the Central Pollution Control Board, 48,000 million liters per day of wastewater is generated in urban India, comprising of class 1 and class 2 cities only. In Maharashtra, we generate about 7,000 MLD, excluding rural areas, and only about 30% of it gets treated across this country. And the treatment level available in cities with existing treatment plant varies from about 2.5% to 89% of the sewage which is generated in these cities. So the treatment can be as low as negligible to as high as almost 90%, depending on the size and the place of the city. Now, untreated sewage discharge is one of the most important causes for surface and ground pollution, which has been iterated regularly and which we all now understand very clearly. And decomposition of organic material in the wastewater generally leads to malodorous gases, impact on aquatic flora and fauna, and odor issues, mosquito nuisance, breeding of insects. Rivers are degraded, beaches are degraded. E. coli and pathogenic microorganisms can contaminate drinking water. So the list is endless. So we have been reading all of this for a very long time. So a few years back, when researchers at NEERI were looking at the wastewater treatment methods, which are still being used, right? They asked some questions. What if because most of these treatment plants, conventional treatment plants, they are dependent on all of these questions. So the very first question: what if there is no power? So the moment there is no power, uh, power by I mean electrical power. So the moment there is no electrical power, right, all of these treatment plants cease to operate because you need power to run the motors, you need power to do the aeration, you need power to pump the sewage. So we are dependent on electricity. Question number one. Question number two, what if microbes can't survive shocks? What I mean by shocks is the shock loading. So, we all understand that in wastewater treatments, there are times when there is a lot of inflow and there are times when there is a very low inflow of the sewage. So, These shock loadings normally are not very well absorbed by most of the treatment plants, and that leads to low treatment efficiencies, or sometimes untreated sewage actually flows out as an effluent. What if there is no trained manpower? Now, all of these treatment plants, if people in this meeting have visited even one of it, right, they must have seen that you need trained manpower to operate these treatment plants, right? What if there are no operation and maintenance funds available, right? So these are some four questions which are uh, which are basically related to the operational issues around our treatment plant, and which are very much the issues whenever we talk about treatment plant not working, right? So either there are no funds, either there is no manpower, either there is some shock loadings, either there is no power, electrical power, right? The other questions which normally, um, are more aesthetic in nature, right? Is that can we stand near a sewage treatment plant? Because if you talk of mega cities in our country where we need decentralized sewage treatment facilities these days, we don't have enough land. So can we actually create a sewage treatment plant right in the middle of the city? So can we stand near a sewage treatment plant, which means that can a sewage treatment plant be odorless? Can it be noiseless, right? Can we sit and eat and recreate around a sewage treatment plant? Now that's like sitting in the toilet of a house and eating food. So can you actually recreate around, because STPs require large areas of land, and the moment you provide those large areas of land, right, they are demarked as not habitable. Nobody can move around it, right? So recreation is another thing which is not possible now. Can a gardener understand sewage treatment plant? So can it be simplified to a level of a gardener so that it can operate on itself? Can the sewage treatment plant also be part of aesthetics, right? So can it be a place where people would go and picnic on a weekend, right? And it can have a very good background for taking pictures, and it can look very beautiful. And at the end of it, can I use the treated water, right? Treated wastewater, whatever is coming out of it. So these are some of the questions which were answered in a patented technology by CSIR-NEERI, which is known as the PHYTORID technology, right? So PHYTORID is a modification of constructed wetland technology. So in my last talk, which I did with you, I talked about PHYTORID technology being employed, right? And I also talked about some of the applications last time. This time I would deal with another site-specific application in the next few slides. But just for the information of the public at large, is a modification of a constructed wetland technology. Basic concept is removal of the pollutants in wastewater with the help of plants. So we are using plants which are basically consuming all the biological oxygen demand of the wastewater. The basic units are not very different. There is a sedimentation tank, there is a planted bed, which is also known as the phytorid chamber, and then there is a treated water collection tank. So not many ancillaries. It's a very simple three-step process, and it's a system with both aerobic as well as anaerobic treatment in one sewage treatment plant, right? This is the typical schematic of it, which I had already talked about in my last talk. I'll just leave everyone to look at it for a minute. So we have the sewage coming into the sump, then to the settling tank, then to the phytorid bed, and then the treated water tank, which is basically pumped for reuse, and it can be reused for the irrigation or gardening or farming, whatever. So some of the highlights is negligible maintenance cost. System looks like landscape and gardens. It doesn't look like a sewage treatment plant. It complies with the regulation laid down by CPCB and all state pollution control boards. qualified for green rating credits by IGBC under water efficiencies, allows reuse of grey water up to 95%. Right. Some of the salient features also, it is included in national environmental policy, combines physical, biological, and chemical processes. There is no power requirement. There is low capital cost compared with a standard sewage effluent treatment system. Very simple construction, very low maintenance, no odor or mosquito nuisance, though sometimes it is reported, but it is basically because of some other reasons, not because of the technology. And it is aesthetic and it has a scalable design. So I would stop here with the features of the technology which I would be talking about today in one of the recent, project which CSIR-NEERI uh, has completed, which is restoration of Jogida Lake at Panch Pakhadi, which is in Thane district, close to Mumbai. Right. So if you are aware of Mumbai, Thane is a sister city of Mumbai. So when we started the project, what does the lake look like, and why am I talking of lakes immediately after talking of phytorids? Because a lot of this phytorid technology was has been employed in cleanup of lakes of late, because it requires small amount of land, and generally we have seen that most of the lakes or water bodies in the cities in our country, they are basically polluted by some ingress of sewage, right? And making a very small 1 mld, 2 mld, 5 mld sewage treatment plant using phytorid technology generally helps quickly rejuvenate the lake to its original form. And also the treated water can actually be fed into the lake itself, right? So that the lake is filled with water, right? So where is the lake? So in these pictures on the right, we don't see the lake anywhere. So when we got the project, we could barely see some part of the lake. But yeah, most of it is either full of sewage or garbage. It is encroached and vanishing, completely built up. In varying degrees of environmental degradation is what we can say. So what were the suggestions for lake restoration? So we said that okay, in order to rejuvenate the lake, we can trace the natural or groundwater sources, or diversion of treated wastewater. These are the two things we can do, right, for the restoration of the lake. But before that, what are the steps we have to take? So these are some pictures of the what you call you know the lake right from the year 2000, and we can see that the lake area has been shrinking over the years. So in 2000 it was almost this size, and in 2005 and 2010 we can see the encroachments actually right all around the lake increasing. So what was the update that time that Jogila Lake is lost under sprawling, probably unauthorized construction and rapid urbanization? Initially, it was observed that the entire lake bed was covered with concrete structures by slum dwellers and certain commercial establishments, right? So when I say present, I mean 2019, 2020, early 2020, just before the lockdown. So that was the status then. And So, encroachment of some slum dwellers can be seen, and the lake is nowhere to be seen actually, right? So the administration actually started demolishing the illegal structures, and a lot of this was demolished, and barricading work was done of the demolished area, right? And we then delineated a scope of work, right, so that a detailed project report could be prepared, right? So what are the steps of a DPR preparation? I would discuss in a few slides. That from the local municipal corporation we seek historical documents, city development plan, or Gathan map indicating the location of the lake. Other available details or records or reports of the lake, such as the original area, the extent, the depth of the lake bed, and any of the data which would be valuable for the preparation of the project implementation plan at the later stage. Also, the rainfall data from the regional Met Center is to be collected, and a demarcation of exact boundaries of the restoration site, and it would also require excavation of the lake to its desirable size and making available the clear demarcated portion with boundary details, right? So we get all of this information, and we do all of this, right, so that we can actually proceed with the DPR preparation. The other part of it is data collection and survey. So total station surveys are required, contour mapping is required. We also need to do some testing on the soils to understand the bearing capacity. We do boreholes for permeability test. Geophysical surveys are required. Natural stormwater drainage pattern of the area is very important to understand as to, because a lot of places we have seen that because of construction activities and because of concretization, right, the natural stormwater drainage pattern has been altered. So if we understand the original stormwater drainage pattern, we could still have some underground, alleys and underground ways so that we can get the water reach the stormwater reach the lake, because stormwater is mostly clean. It doesn't require any treatment, right? It is pure rainwater, so it's very good for the lakes. Aquifer test and analysis for wastewater quality are some of the other things which are also required. Is there is there a question?
Sorry, sir, there was some disturbance.
Okay, so what are the options now? So I talked about recharge the lake by natural streams and rainwater. So the approach would be to study the natural stormwater drainage pattern of the catchment area and the probability of these natural streams recharging the lake, because of urbanization, rapid urbanization. Probably the stormwater may never reach the lake, right? A very classic case study which is also being taught in first year engineering courses these days. It's also a standard textbook now. Is how the lakes in Bangalore city vanished over the years. So it's a very pertinent and a very well-known factor that most of the lakes in Bangalore was known as the lake city at some point of time. It still houses a lot of lakes, but a lot of them were lost because of the increased demand of houses when Bangalore became the first Silicon Valley in our country. So a very rapid urbanization led to mass destruction of these lakes, and most of the lake beds were actually covered, and buildings were erected there. Also, the study of water flow in aquifers and characterization of aquifers for recharging of the lake by natural springs, if any, in the area. Analyzing the annual rainfall pattern and available rainfall data for the catchment of the lake to augment the water in the lake so as to understand how much water would normally, be falling in the lake. And we also account for evaporation and percolation or seepage losses, right? The option two is recharge the lake by diversion of treated wastewater. So if we do have any wastewater treatment plant around the area, can we actually, divert some of that water, treated water to this lake? So quantification of volume of treated wastewater required for the recharge of the lake, provision of inlet and outlet arrangements of the quantified, volume, conceptual design of the appropriate treatment system, and assessment of space adequacy. So is there a possibility of it? We also go for the analysis of site-specific requirements which are related to installations, continuous operation and maintenance of the system. So do we have, so just beyond the lake, is there enough space available for any kind of installations we want to do for O&M, right? Preparation of basic design for implementation of recommended treatment option. So the treatment option can is not only fighter, it can be any wetland technology or any other methods, conventional treatment methods. Provide technology implementation plan along with detailed estimation of project cost, and then submission of the final report with design drawings and cost estimates for the execution of the project. So I'm basically taking it from the step by step of our experiences of doing this project, right? And this was the conclusion of our survey report. So the current site, had four numbers of shallow open wells, which tap unconfined aquifer. Most of the well water was polluted by percolation of domestic drainage water. Hence, to use well water was difficult either for domestic or gardening purpose, and no bore well was also located in the site. and the present water table showed gradient towards the lake area. So that was a good part. Silt, sand and clay formation of sedimentary deposit and jointed, fractured and weathered amygdaloidal basalt are observed, which were water-bearing formations. So, the geology of the area is suitable for carrying the lake. Site may have both unconfined and confined aquifers, which was not very clear. The resistivity data showed that the average depth of bedrock or hard rock was about 6.5 meters below the ground level. So there is scope to dig up lake up to 8 meters below ground level. And if the groundwater is to be tapped, the lake water will have to be further excavated below some 8 meters. And the final word was the restoration of lake will have to be planned and estimated by combination of both natural resources and by diversion of treated sewage or wastewater through sustainable treatment technologies. So that comes to the culmination of our initial 2 years of work or almost a year of work, right? And this was the proposed restoration layout, right? So you can see these drawings here, and these are some of the other amenities which I was talking about, right? That can we develop the lakefront to also host children's play area or a pathway or a place to picnic or a place to house an open air gym or something like that. These are some other details which I would skip in the interest of the time. These are some of the methods which had been employed in our previous studies, like Gabion wall structure for the bank protection. So we have seen that normally, if you don't have these kinds of structures, the lake again would actually be flowing. The water may flow out of it, right? So these are some of the examples of it. These are the first two pictures. Bank protection at Belapur. These are in New Bombay, right? This is pond lighting in seaside in Cochin, and this is another pond protection work in Cochin. Uh, uh, and we proposed PHYTORID technology, the benefits of which I have already talked about. So, I will not go over this again, but I would just say that it's a simple solution for sewage treatment, right? To the eco-friendly, it was very much doable, right? And we have talked about filter media and plants, right? So, filter technology is basically a subsurface flow type technology, and the wastewater is applied to cells or beds, right? Which is filled with locally available porous media. So the filter media basically is a unit which is using gravel, stone, and debris, right, which is available locally, and some plants which are aquatic, semi-aquatic, or ornamental, and also flowering species at times. So we, as I said in the beginning, there's a screening chamber and a thumb well, a sedimentation tank, a filtered bed, and then we do some tertiary treatment using ACF plus PCF and chlorination, right? And this was the last known status of the lake, which was in June 2019, right? So the barricading had been done, the excavation was in progress, right? So beyond that, the work got stopped done because of lockdowns and no funds. Again, the work is now being started. So for this, this was something which had been done very recently. So I wanted to talk about this work. I have other examples, like Rajokri water body, which we did some time back in New Delhi. So it has some good pictures, so I thought let me share this one, in this in this talk. So Rajokri is a well-known town in southwest region, in Delhi on the Haryana border, and there are issues of the lake was the picture speaks a lot of itself. The lake was totally sewage laden, and it was not in a very good shape, right, before we started the restoration work, right? And the site was fully enclosed by an existing boundary wall which was stopping the flow of surface water from a larger catchment area to the water body, and punctures have been created in the wall along the Abadi edge to allow surface drains carrying grey water. So instead of the fresh water coming into the lake, grey water was actually going into the lake, and encroachment were on the three locations at the site that those were observed, right? High contamination levels were observed. Sustained solid waste disposal was there. Sludge deposits are there. You know, there was no willingness for anybody to even look at the lake, right? It was totally neglected, right? So we came up with a restoration plan wherein we said that how we can trap and clean the water body, how can remove the historical sludge which is there, creation of enhanced capacity to hold monsoon flow at the site, then restoration of the larger catchment of the water body and its reconnection, right? So when I said that the lake was covered by boundaries from all sides, the naturally flowing water was not coming to the lake. Appropriate creation of ghats in an environmental friendly manner, right? So which you will see in the pictures next, right? Creation of ecologically designed and easy to maintain landscapes for the use by public, and putting in place a management regime which is sustainable for the long term, and which is workable with the community as a key stakeholder, because the people who are dwelling in and out of that area are the ones who would hold it as a very as a gem of that area. So it's like if you create something very beautiful, people would not want to then further um, dirty it. Like a very classic case of Indore city, which has now come number one in India again for cleanliness, right? Fifth time in the row. So congratulations, people at Indore, right? That they are again number one. And what I realized when I was last in Indore, that even if you want to throw garbage somewhere, or even if by mistake if you throw, somebody will stop you and say, boss, please pick it up and throw it in the dustbin. So that is the kind of that's what is engaging the stakeholders. So people of Indore have actually taken up that, okay, now we are clean and we want to remain clean. And I think that is what is pushing, you know, more than any government policy, the participation of key stakeholders in the process. And this is the Rajokri Lake before and after, right? So you can see the whole area has been transformed. The landscaping has been done in the picture below. You can see, right? So it was one of the very successful projects which was implemented, right, by NEERI, right? So you can see the beautiful landscape now. So all these trees were there only. They were not planted. They are hundreds of years of old, right? But the whole area was restored, and the strategy was basically water harvesting, you know, and then we created some swale and bioremediation grasses, seasonal ponds. So the levels and grading of the landscape was planned to facilitate water harvesting. The pathways and hard areas would all be connected through natural swales to catch the runoff from the ground. The grasses around the ghat would clean the water from the shale through bioremediation. The swales would all drain towards rain garden, which will be a low-lying area, and the rain garden acts as a primary collection area of the rainwater and recharges slowly the groundwater. Right? So a very beautiful, amalgamation of all the thought processes and you know landscape strategy, which we say that so this is another depiction of the same thing which I just said, right? That how the drainage process would happen. So surface flows would come in, right? And then there are swale areas, and then there is a rain garden here, and then overflow channels are also there for direct entry of the water into the lake. The drainage component, rain garden, perforated pipe swales, these are well-known things, so I will not dwell on these. Yeah, these are some of the species of, locally available, very, easy to, grow in that area. They were used, right? And what was the ecological impact? We could restore the flora and fauna, right? Sighting of migratory birds, kingfisher and ducks was seen in 1 year of the project. Announced groundwater recharge with good quality of water was there. Clean water body resulting into eradication of diseases in the area. Social impact, huge social impact. People were connected to the water body, right? As is, people now have a community space for recreation. Children play area is there. Safe public space. All antisocial elements and activities cease to exist. Community ownership. The Chhat Puja Samiti ensured general upkeep of the water body, right? So that is how we could actually engage local public participation and actually rejuvenate. a lake. So it's not only the government, it's not only the policy, it's not only the fund, but it's also the stakeholders engagement, which is very important when we talk of some of these cases, right? Another similar project by NEERI was Shadra Lake, that too also was in Delhi, right? So treatment of wastewater through Phytonic technology for revival of Shadra Lake, with a lake bed surface rejuvenation. Um, Pelibanda Lake, which is in Raipur, right? It was the XC2 lake treatment system. So treating inlet sewage before discharging it into the lake. Then we were combining two inlet streams into making a single, plant of capacity 1.5 milliliters per day, right? Setting up a 1.5 MLD PHYTORID oblique swab-based sewage treatment plant, and then it basically considered of the same screening sedimentation at PHYTORID tanks. The in situ lake treatment was done using floating rafters. I haven't talked about floating rafters yet, right? But I have another, some slides on floating rafters, which let me see if I can talk about it. Hmm, What are these floating rafters? Okay, so we go to floating rafters for lake water remediation and conservation of reduced water stress. So again, this is typical natural drainage pattern, peripheral wetland ecosystem, which we are talking about. And I come to this lake again, Shadra, right? And what is NEERI solution? What is floating rafters? What is the principle behind floating rafters? Also called flow rafts. So we all understand that there is a biofilm which covers the island and the plant roots, right? So there is a matrix of a light floating material, right? And the plants are actually sewn into that, right? So the root has actually developed a biofilm with microbes. These flow rafts can then be you know tied down to a nearby tree or poles so that they don't flow away, right? They stay in a narrow zone of water. And these pictures, you can see that these are some of the you know uh, flow rafters which are designed. How does it work basically? So carbon sequestration occurs in this, so leads to fodder generation for cattle and biomass for fuel, which is about 50 to 70 kg hectare per month, reduce evaporative losses by almost 30% by covering lake surface, right? Leads to growth of fishes and thereby leads to water conservation, local fishing and livestock feed. You know, so this is another lake in Thane, Makmali Lake. So before installation, it is a highly eutrophic, nature clearly visible of the lake, right? And after the installation of these, so these are the flow rafts which you can see in the lake, right? If my cursor is visible to you, right? So the status before the BOD was more than 200 milligrams per liter. The TSS were more than 180 mg per liter. Phosphates and nitrates greater than 30 mg per liter. The status which was reported after the installation was that BOD reduced to almost 90%, which is in the range of 10 to 20 milligrams per liter. TSS almost again reduced by more than 90% to 10 to 15 mg per liters. Phosphate went down to just about 1 or 2, and nitrates were in the range of 5 to 10. So all this by just floating some plants in the lake body, right? So this is some these are some slides on floating rafters I wanted to share. Okay, these were some news clippings which were there in the newspapers that how the fighter swab based treatment plant has done great. The Telibanda Lake model also bagged the National Excellence Award, right? Raipur Smart City, they got National Excellence Award. These are some of the other water bodies which where we are working in Raipur now, right? Which is Nariya Talab, Kari Talab, Dhobi Talab, Ramkund Talab, Amma Talab, right? You can see all of these are not in the great shape right now, right? And then these are another Kankali Talab, Katora Talab, Khoko Talab, and this is now Praladva Talab. So a lot of work which is. Uh, I would want to stop now, and I would want to say that the presentation is adopted from the reports of various studies by scientists and technical staff from CSIR-NEERI, and they are highly acknowledged. And inventors of PHYTORID technology and fluorof are also acknowledged. Thank you. I'll be happy to take questions.
Thank you, sir, for the wonderful presentation and the practical application of this phytorid technology. I would request the participants if they have any questions or if they would like to interact with sir, you can unmute yourself or you can even type in the chat box. So can phytorid be used for this restoration of nala and canals as well?
Thank you for asking. Uh, uh, that was precisely which was left out, right? So we have we have been working on Nala cleanup, right? So let me share a few slides on it. Right. Okay. Where did we go? So, see my slides now.
Yes, sir.
Yes. I was actually looking that I missed the Nala cleanup part of it, right? And thanks for asking. So these pictures are pretty common in our country. You all of us have seen them somewhere or the other, right? The this picture is just next to Taj Mahal, right? And these are common views in almost all the cities and smaller towns in our country, right? So uh, what we have done is basically, I'm sharing this Nag Nadi Nala, right? It was about 6.4 meters wide, and was depth was only just about less than a feet, right? So length of 500 meters between the University Road and Panchsheel, was basically adopted to actually install, right, the Phytorid system, right? And we were talking of a plant capacity of 1,000 cubic meters per day, right? Entire length of the plants, which we estimated was 267 meters, right? And length of alternate bed was 184 meters, which was about 8 meter wide and about 1.5 meter depth, right? So we talked of you know, dredging with the thought it is high capital cost, aeration not very effective, bioremediation failure till now at all field installations. So what was the design criteria of the Nala cleanup, right? So we went to the schematic drawing, we went through the design criterias, and we actually set up uh, a floating rafter come an in situ Nala technology, right? So wherein we actually installed the similar kinds of flow rafts as well as Phytonic technology both in them, right? And this is the picture of the Nala currently. So yeah, they are available. In short, what you're saying, right? There is another technology known as Reneo. So maybe next time when I talk about it, I would be happy to share the technology of Reneo too.
So
Right?
that
Just
renew is also
recently,
based upon phytorid only.
has similar components.
So anybody else who would like to ask anything? I thank you, sir, on behalf of the Civil Engineering Department at IPS Academy, Indore.
No,
And
thank you
we are
so much.
highly privileged and honored that you could enlighten
Ma'am,
us
ma'am,
regarding.
I have one question, ma'am.
Sure,
Yes,
sir,
please
please.
go ahead. Please introduce
Which type
yourself.
of plant? Which type of? Pardon, sir?
Can you please introduce yourself so that I know you?
No, sir. No, sir. No, sir. I am
So
practicing, sir.
please,
Civil engineer.
introduce yourself.
I am Venkatraman from Tamil Nadu, Madurai. I practicing a civil engineer.
You are a practicing civil engineer. Okay,
Yes,
okay,
sir.
okay, Venkatramanji. Boliye.
Which type of plants uh, have to grow and propose to this type of method, sir?
Okay. I will just go to that slide.
Okay.
So we have an array of plants which you can use there, right? So we can have, wetland plants, which are bulrush, nutsedge, kanna, cattails, right? These are locally available, right? We can also go for, I had another slide around it, right? Okay, there's the one here.
So setting up of flowering plants is also possible.
Yes, why not? So I talked about these. So grasses, trees, climbers, so trees, I mean, this is around that area, right? If you're typically talking about the plants which can be used in phytorid only, right? Then these are these, which I talked about, right? These are the plants which, these are the wetland plants basically, right? So most of this phytorid technology is being implemented through technical know-how being transferred to the license holders of NEERI technology. So you can contact the NEERI headquarters, and they would let you know who are the partners, and they have all the technical know-how around this as to how to implement it. Venkatramanji, did I answer your question?
Venkatraman sir, do you have any other query?
Yes, sir. Yes, sir. Thank you, sir. Thank you very much, sir.
Thank you so much. Thanks.
So anybody else from the participants? So there is no restoration work in Indore regarding phytorid.
No, there is currently, last 1.5 years, the things have been slow. We were in talks with a lot of smart city people, right? But there are a lot of projects going on. My senior Dr. Ritesh has been working right closely with the MP government, right? So I'm sure he might have some news around it, which I'm unaware of right now. But I'll let you know. Otherwise, right? If you're doing something in Indore, I heard some things have been done in some other towns in MP. Indore, I haven't heard about.
So there is a lot of scope left to be done, sir.
Yeah. There's always more to be done. We are a country full of natural resources, and you know, uh, just today morning I was listening to the environment minister. He's in Mumbai for a workshop. So basically we are talking of air quality right now, because you must be aware that in this time of the year, Delhi air quality is takes up the center stage in the country, right? Because of high pollution levels, and so a lot of it boils down to saying that it is we should all look at that we are not uh, we haven't whatever natural resources we have, they are like वो उधार है हमारे बच्चों का हमारे ऊपर, basically we have to give it back to them, right? So for future generations we should actually preserve them so that we can give something to them. So I think that what he was saying.
So I have one more query. Like
Yeah.
recently, I came across that there is some like concept that wall can be put into these nalas and canals, and then that wall can will be able to treat it. Sir,
I
what's
I
your
I
opinion
haven't
about it?
I haven't heard about it. Wall, but definitely a lot of people are coming up with innovative technologies. So what I can understand immediately when you're saying that there is a wall, right? It might be a similar kind of a thing, wherein we are talking of floating rafters, wherein we are talking of in situ treatment of, you know, so that wall might be doing the same, filtration, sedimentation, taking up of the, you know, what do you call BOD from the wastewater. The wall might have some pockets wherein some plants might be growing, right? So yeah, I'm sure that is possible.
Sir, did you also test the water after installing this phytorid?
Yeah, I hope I talked about it last time. That's why I didn't talk about it much this time, right? But if you look at the efficiency of phytorid treatment, right? So, is the slide visible?
Yes, sir, it's visible, sir.
Okay, so you can see, conventional, this is performance comparison with other technologies, right? This is published data, right? So BOD removal, we are talking of 87 to 95%, right? Sludge, we are saying it's negligible. Equipment required, excluding, screen removal, grit removal, minimal, mostly gravitational flow. Operational, all these things do require skilled operator, it's not required here, and no power is required, right? And these are this is a you know mechanism applications are talked about, design considerations, and this is the treatment efficiency of the first phytoride plant, which was established in 2006 in Kalina campus of Mumbai University, right? And these are the percentage removals which are there. So from 2006 to 2021, in 15 years, the technology has grown, right? So it started with a very low loading rate, and now I have heard that people have scaled it up to 10, 20, maybe 50 mlds also, right? So it's definitely a scalable technology.
So regarding the application of this technology on an individual home basis, is it possible, sir?
Mm.
Like independent houses
Community
can even use
community
this?
basis community basis, we can say, because we would need a certain minimal flow, right? That's what I understand best. But haven't heard of any experiment yet for an individual home basis. Maybe I should find it out. uh, maybe a maybe what you're looking at is a colony basis. It can be done on a, like in Indore there are so many colonies, so it can be done on that community level. I believe yes, right, and it will also give you a good garden and some greenery in that area where the sewage is flowing. So it can be done, yes, especially open nalas and drains. Right? Those can be treated well.
So, thank you so much, sir, for the wonderful technology that you have shared with us.
And
And
thanks to the inventors of the technology, I am only a spokesperson today, right? And a lot of good work needs to be done. Thank you so much for inviting me to be able to share some of this work, right?
but the
And
way you
this,
explained it was very nice, sir. It was
thank you so
very
much. I have been a
understandable.
teacher all my life, and I love to talk. The only issue is that I can't see students now. I can only see my screen, right? But it's always a pleasure to come back to any classroom and share some information and knowledge.
So
Thank you so much.
there are some advantages that we can get knowledge from you, and there are some disadvantages that we are not able to interact with you in person.
No, no, but I think now it's opening up. So maybe next time we should
Yes,
we
sir.
should meet in person, and maybe in your
Yes, sir.
college, I can come and coming to Indore is
Definitely, sir.
always fun. Thank you.
Looking forward to it, sir.
Sure. Thanks.
Thank you so much, sir, for giving us such a valuable information and taking out time from a busy schedule, sir.
I,
We look
I, I
forward.
hope I finished in time. I think we are early actually, right?
Yes,
You
sir.
gave me
A
one
bit
hour. I think
early,
we finished
but
quickly.
I feel so. Whatever knowledge we get, even in short time, that's more important. And
Thanks.
rather than like sitting for 1.5 and not understanding a single point, it's better that we make it concise, but at least we understand the basic concepts of it.
Thank you. Thank you.
Thank you so much, sir. We look forward to meet you in person sometime, sir.
Sure, sure. Bye
Thank you once
bye. Thank
again.
you.
Bye, sir.
Bye everyone. Thank you. Thanks for hearing.
So the participants are now requested that the next session will be around at 2 p.m. Uh, I will be giving a reminder call as the session starts in the WhatsApp message group. I hope to see you again after lunch. Thank you.